So today I was wondering how much of a cup of tea do I need to fill, like optically, height-wise, so that it fills half a cup of tea? Because obviously it's not half, as the top of the cup is wider than like the bottom, right? So let's assume a cup of tea is a frustum of some cone, right? And uh, so let's just say this is the full cone, and that part of the thing is the frustum. So let's just make this a dotted line. This is like a dotted line, this is like a dotted line. So let's say that, wait, let's define some radiuses. So let's say that this radius is capital R. Let's say this radius is R1. Let's say this radius is R2. Let's say the height of the cup is H. Let's say the height of this cup, the height of the T actually is H dash. And we can say that this remaining height is some capital H. So we know that the volume of a frustum is equal, which is basically the volume of the cup. So if the terrible handwriting is 1 by 3 pi H capital R square plus R2 square plus R R2. Now similarly we can actually say that the volume of the liquid, if we consider this part to be the cone, like we consider this as a cone, right? Just this part as a cone. We can say that the volume of the liquid is equal to 1 by 3 pi h, but this is not actually h dash, pi h dash is going to be, again, the cone is this, so it's r1 squared plus r2 squared plus r, sorry, wrong r, r1 r2, right? And now since this is an entirety of it is a cone, right? So we have like this. Okay, sorry, I put that up a little. So, like, we can consider this triangle for. So wait, well, let me just say this is the volume of the cup, right? This is the volume of the cup. So we know that we want the V liquid to be half of the volume of the cup, and so we can divide these two and get half of the result. So when we divide V liquid by V cup, 1 by 3 cancels out, pi cancels out, so it's H dash by H at the top, R square plus R2 square plus RR2. Sorry, this is the wrong side. It should be R1 squared plus R2 squared plus R1 R2 divided by capital R squared plus R2 squared plus capital R R2. Now this should be some way to derive the relation between the heights and the radiuses, right? Because we have this big triangle here and this big triangle here. So what we can say is that since these are part of the same cone, that these will be similar triangles because the angles will remain the same, as is a fundamental property of a cone. And here we will have that h plus capital H divided by the Okay, so we consider this big rectangle. This is basically uh, r divided by something, and we consider a second triangle which is um, h dash plus h is equal to r r1, right? And we also have h dash by h. Now h dash plus h by h equal to r1 by r2. So here we can actually simplify this a little and say that h, this is h dash. Okay, let us clarify this a little bit so it's simpler to read. So we can say that h dash plus h is equal to r1 r2 by h, right? So we can say that h, I can actually say capital H r2 is equal to, sorry, capital H r1, capital H r1 is equal to r2 into h prime plus capital H. And here we get capital H is equal to r1 minus r2 this multiplied h r1 minus r2, which is a divisor of r2 h prime, right? So we have this relation, so we can just plug in some numbers here. So we have h plus r2 h prime divided by r1 minus r2 divided by h dash plus h dash plus the same number r2 h dash by r1 minus r2 is equal to capital R by r1. So now we have r1 minus r2 h plus r2 h prime divided by, this should be equal to half, by the way, r1 h prime is equal to r by r1. So r1 and r1 cancel out, and here we have capital R equal to r1 minus r2 h plus r2 h dash by h dash. And of course, let's not forget that h is the height of the cup and h dash is the height of this thing. So now that we have this relation, we can just plug this into Wolfram alpha, because I'm not solving for this. This is a pain to solve for, and let's just see what we come up with. Okay, so I forgot to actually add this kind of this h here. So this should be an h over here, right? Or a h. Now the way to solve this is actually pretty simple. You just take this expression for r, right, and you plug it into this relation instead of r over here and r over here, and you should get some relation between h dash and h. So that can be left as an exercise to the reader. My Wolfram Alpha says that the solution is like a really complex number that it has solved using some differential equation, not differential equation, sorry, some basic algebra with like cubic equations and etc. etc. So it comes out that this relation is that h dash should be approximately equal to 0.6478 of h, and this is a final result. So if you want to fill a cup of tea half full, or you want to fill a glass of water half full, then you should be striving to achieve this ratio of 0.6478, which is like between halfway and three-fourths is a pretty good way, I would say, to kind of estimate. Thank you for coming to this lecture where we half solved the equation and used Wolfram Alpha to solve the rest. But this is completely solvable if you just like put a lot of effort into it. It's just typing or like writing on a computer screen is really obnoxious, and my handwriting isn't the best here. But like if I did it on a piece of paper, then it would have been much better. But I don't really have a camera, so it's kind of awkward. But yeah, see you later.